This is Mark. Mark works as a carpenter and relies on his hands to do his job. He lost several fingers in a recent accident and now struggles with fine motor movements, such as using power tools. He doesn't wear prosthetics because they can't provide him with any sensory feedback, so he finds them to be more cumbersome than useful. Mark's story isn't uncommon. The loss of a limb is a traumatic event that impacts an individual's level of autonomy and causes negative psychological effects like depression and lowered self-confidence. There are over 10 million amputees in the world, many of whom will experience physical challenges in everyday tasks like tying shoelaces, cooking food, and driving cars. In a healthy person, the brain coordinates movements by sending signals to the muscles, then using the sensory information it receives to make adjustments. When an amputation occurs, the sensory feedback pathway is cut off, causing high levels of cognitive burden to the individual as they must now rely on their vision to monitor their movements. Some prosthetics can transfer EMG signals from the residual limb to the controller, but we would like to implement the second half of the control loop, the sensory feedback. We want to design a low-cost device that provides sensory feedback to reduce the technological and communication barriers that prosthetic users experience, and we're focusing on a solution which is economical, accessible, and non-invasive so that it can benefit anyone who needs it.
To do so, we follow the human-centered approach to design the most appropriate solution because we want to focus on the people we're designing for.
The inspiration of our project came from Mark's story. But in order to truly understand the context and needs of the stakeholders, we talked with amputees, neuroscientists, and prosthetic technicians.
In the ideation phase, we brainstormed ideas and did market research to find a design gap where our solution would be successful. There doesn't exist a commercially available non-invasive sensory feedback prosthesis that is accessible. As a designer, I sketched mock-ups of how our solution would look like, which we showed to Mark to get insights from him.
So to implement an early prototype, our engineering team brought together our combined technical experiences in mechanical, electrical, and biomedical design. So we're using force sensors on the fingers and palms to measure tactile sensations, then transforming the signals into vibrations which could be felt in the upper arm, and we're just showing that through the LED visual display. Our prototype is adaptable to many different types of prosthetics since it's essentially a wearable, so it's very accessible and very low cost. One of the challenges that Mark mentioned was that he would have trouble using power tools as a carpenter, but through our device, now he could regain some of that ability. So in the future, we're hoping to reiterate on the design process by gathering more user test information and seeing what they want and what is still missing from the design.
So thanks to a human-centered approach and by combining the strengths of an interdisciplinary team with the point of view of our users, we were able to create haptic.
We're excited to see where the project goes.